Hello everyone. So here we have a question. We have to determine slope at A, okay, slope at B and slope at C. We also have to determine deflection delta C in the beam, okay. So all this we have to do by conjugate beam method. So in the conjugate beam method, the very first step is we have to convert this real beam into a conjugate beam, and that will be done by drawing bending moment diagram. Okay, so this is simply supported beam subjected to point load at the center, and the bending moment diagram will be WL by 4 positive. The bending moment will be positive. So this value is 120 kilonewton meter. Okay, and this is your bending moment diagram. We have to convert this bending moment diagram into a curvature diagram, and that can be done by dividing bending moment by EI. Okay, so they have given I value for AC and 2I for CB. So how to convert? You see here, for this portion we are having 2I, so we have to divide moment by EI. For this portion you are having 2I, so here it is 120 by 2 EI. Okay, so here the value will be 60 by EI, and C is the junction. At the right side of the C you have 2I, and at the left side of the C you have I. Okay, so it's a junction. So here at this point you will have M by 2I, 2 EI, and at this side you will have M by EI. So M by EI is nothing but 120 by EI. So here it is 0. Now see, the bending moment is positive. For positive bending moment, the loading diagram, the load intensity you have to take downward, and for negative bending moment diagram you should take upward. So here we are taking loading intensity downward. Okay, and now we can apply boundary condition. So we know the boundary condition, various boundary conditions we have. Simply supported in real beam will be equal to simply support in conjugate beam. Here also at B we have simply supported end. So here at conjugate beam it will be same. So I will call this as A dash, this I will call C dash, and B dash. Now what we have to find here? Theta A, theta B, theta C. So slope, shear force at A dash in the conjugate beam will be equal to slope at A in the real beam. So this is our conjugate beam. Now we have to find theta A in real beam. Now we know the point shear force at A dash in conjugate beam is equal to the slope at A in real beam. So we have to find here RA dash and here RB dash. Shear at A dash is nothing but RA dash. We have to find RA dash. So how we can find it? This is 4 meter, this is 4 meter. If we take bending moment about P dash and equate it to 0, we can able to find RA dash, and we after getting RA dash we can easily find RB dash by using summation of f of y equal to 0. So first we have to find RA dash. So RA dash, we have to take bending moment about point B dash and equate it to 0. Now you see we are going from left to right. Okay, so in this case RA dash into 8. Okay, So then we have this triangle. We have two triangle between A dash and B dash. So we have this triangle. The height of this triangle is 120 by EI and the base of this triangle is 4 meter, and the total load of this triangle will be acting here. Total load is nothing but area of this triangle, okay, and which will be acting at the centroid of this figure. Total load is half into 120 by EI into 4. Okay, so I will write here total load, and this will create anti-clockwise moment, and we have to take here negative. Okay, half into 120 by EI into 4. Okay, now this distance we know, this will be 4 by 3 centroidal distance from this side, and we have to take perpendicular distance up to B dash. So 4 by 3 plus 4. Okay, so perpendicular distance is 4 by 3 plus 4. Now after that you have this triangle. Height of this triangle is 60 by EI and the base of this triangle is 4 meter. Total load will be acting here. Total load, which is half into 60 by EI into 4. So again this will create anti-clockwise moment. Write down here, minus half into 60 by EI into 4, and centroidal distance from B dash will be 2 by 3 factor into base. Okay, you know this, 2 by 3 into 4 equals to 0. So RA dash you will be getting by solving this equation, RA dash equals to 200 by EI. Now you see, if you want to calculate shear at A dash, at A left it is 0, at A right it is RA dash. Okay, so shear force at A dash equals to 200 by EI. This is about conjugate beam, which is equals to theta A in real beam. So theta A equals to 200 by EI. Okay, which is this is about real beam. Now we have to find theta B. To find theta B, we have to find RB dash, which is shear at B dash. Shear at B dash in the conjugate beam will be equal to slope at B in real beam. Okay, so find RB dash. How can we find RB dash? We have calculated RA dash 200 by EI, and we have to find RB dash by using summation of f of y equal to 0. Now see, I will write here summation of f of y equal to 0. RA dash is going upward, so I will take it as a positive 200 by EI. This two triangle, the total load of two triangles are going downward, so I will take it as negative, minus half into 120 by EI into 4 total load of this triangle, minus total load of this triangle, half into 60 by EI into 4, plus RB dash is going upward, RB dash equals to 0. So RB dash you will be getting by solving this equation, RB dash equals to 160 by EI. Okay, so now see here, shear at right of B is 0, and as you go from right of B to left of B, RB dash is going upward. So when you are going from right to left, the force which is going upward shall be taken as negative, and the force which is going downward shall be taken as positive. Okay, so here theta B dash will be equal to shear force at B dash, or theta B, sorry, in real beam. Okay, which will be equal to minus 160 by EI, and since it is minus, we can call it as anti-clockwise rotation. Okay, why it is minus? Because we are getting negative shear force at B dash. Now we have to find theta C. So how to find theta C? Shear force at C dash is equals to slope at C in real beam. So shear force at C dash, if you take A dash and C dash, RA dash is going upward, okay, and this total load of this triangle is going downward. So you find here shear force at C dash equals to RA dash is going upward, 200 by EI minus this total load of this triangle is going downward, okay, minus half into 120 by EI into 4. So theta C you will be getting, first you write shear force at C dash, which will be equals to minus 40 by EI. So theta C in real beam will be equals to minus 40 by EI radian, okay. So this is minus, it can be termed as anti-clockwise. Now what we have to find here? Now we have to find delta C. Delta C, deflection at C in the real beam. So we have to use theorem 2. Moment at C dash in the conjugate beam will be equal to deflection at C in the real beam, okay. Now see here, I will write here delta C. Delta C is nothing but deflection at C in real beam, which is equals to, now I will write here bending moment about C dash in conjugate beam equals to deflection at C in real beam, okay. So what will be bending moment at C dash in conjugate beam? If I go from A dash to C dash, first force I am getting here 200 by EI into 4, which is clockwise, okay. So I will write here 200 by EI into 4, RA dash into 4. Then you have total load of this triangle, okay, which will create anti-clockwise moment with respect to C dash, and the perpendicular distance is 4 by 3 with respect to C dash, minus half into 120 by EI into 4 into perpendicular distance 4 by 3, okay, equals to delta C. So delta C equals to 480 by EI. So in this way you can find displacement by using conjugate beam method. Thank you for watching this video.